Hello everybody, this is Della from The Beauty of Play with another astronomy illustration. This one is our seasons illustration. We did a large number of illustrations within our astronomy block as teaching illustrations. I use the illustrations for various different things. Sometimes it's to support a narration, sometimes it's to review an art lesson, and sometimes it's a side-by-side teaching of a lesson. In this particular one, it was a combination of many of those things. It definitely was a side-by-side teaching lesson, and this illustration supported our next illustration, which was of the analemma of the sun. So that is the path the sun takes in our sky throughout the year. It makes a little diagonal lopsided infinity across the sky. And we used this illustration to help support the understanding of that process and that illustration. I also use this illustration to help review some of our perspective drawing work from previous grades, where I can integrate other disciplines and other blocks into the current block that I'm doing to help review and enhance memory recall, interleaving, elaboration into our work. I try to do so for long-term retention. We start this drawing with 4 different spheres. You will notice that there is some overlapping with the perspective drawing. The idea is the closer spheres are larger in size, except for the sun, which is far larger. So you see that that is even larger, even though it's farther away than the sphere that we're drawing. And then the one behind it is slightly smaller, and another sphere to the left. These 4 spheres are the Earth, rotating around the sun. We're also using other aspects of art, like highlights and shadows, to create depth, both in the Earths that we were drawing and also in the sun. My favorite way to do shadows and highlights are to use analogous colors. So you will see the color of the sun here, and then I use a yellow, a brighter color, to add highlights, and then I'll use a darker color to add shadow, and that gives more depth. You can also use complementary colors, which are colors opposite on the color wheel, to create the same shadows. So since I'm using this orange for the sun, I could use blue in this sun to create the shadow and the depth, but this gives a more muted color, and I like the brighter colors. So we're using analogous colors, which are colors adjacent to one another on the color wheel. I'm using this light orange yellow and then yellow for the highlights, and then I'm going to use a darker red, which is adjacent to the orange, for the shadows. From here, we're going through and doing the same thing for the Earths. We're using a little green to show the different continents on the Earth, and blue to show the water, and then we're going back in with a darker green and a lighter green to add more depth to the continents. And then after we get the blue in, we take a lighter blue and edge it around each of the continents to create depths for each of the Earths. This is the part of the illustration that we began to discuss the science of the seasons. We are making 2 bisections of each of the Earths. One is a vertical line that goes straight up and down, and this will reflect the light coming from the sun. The next bisection that we make represents the Earth's rotational tilt. This would run through the Earth's north and south. This tilt is what influences where the light hits strongest upon the Earth. You can tell that I've filmed this illustration in real time during a live lesson because you can see me pointing and showing what is happening as we're drawing this illustration. We are discussing the sun as the light source in this illustration and where that light hits on each of the 4 Earths depending on where they are in the picture. With the Earths on the 2 sides, the light is coming on the inside of each of the Earth as the sun's rays come out to each of the sides. The outside of each of those Earths is hidden by the shadows. When we look at the Earths in the front and behind the sun, we see the light hit the back Earth, but we do not see the light hit the front Earth. That area is not seen to us, and we only see the shadow side. After we talk about where the light is hitting, we also talk about where the shadows are. Where are the areas that the Earth is not seeing the sun? There are 2 interesting aspects of the Earth's rotation around the sun that are important to talk about in this illustration because they set you up for a better understanding of the analemma illustration and why the sun's path looks the way it does in the sky across the year. One is that the Earth's rotation is not a perfect circle. It's more elliptical in nature, so it's an elongated or pulled circle. That means that there are times of year where the Earth is actually closer to the sun than other parts of the year. This happens at the equinoxes, which is a little counterintuitive to me because I think summer hotter, the sun is closer, but that is not the case. The Earth is closest to the sun during the equinoxes and farther away during the winter and summer solstices. The elliptical orbit causes the second interesting thing about the Earth's rotation, which is the Earth is not traveling at a constant speed. It is traveling at various speeds around the sun. What is happening if we start at the winter solstice and the Earth is being pulled by gravity, the force of gravity, towards the sun? It is accelerating as it is coming towards and gets slingshot around the sun and then slows down as that gravitational pull pulls it back, and it gets slingshot in the opposite direction back towards the winter solstice position. This means as the Earth moves around the sun during the equinoxes, it is moving at a faster rate, and then when it reaches the solstice position, it slows down a little and then moves back towards the sun in a faster rate again until it gets to the winter solstice. These 2 factors are pretty significant in why the sun's path across the sky through the year, the analemma, makes the appearance in the way that it does. At this point in our illustration, we are going through and placing 3 lines of latitude onto our Earth. The first line is the equator, and the next 2 lines are the 2 lines of latitude above and below the equator, the Tropic of Cancer and the Tropic of Capricorn. These 3 lines of latitude are significant because the direct rays of the sun hit at these 3 latitudes at specific points of the Earth's rotation around the sun because of the rotational tilt. From the perspective of the northern hemisphere, During the winter solstice, the direct rays of the sun, because the earth is tilted, hit at the Tropic of Capricorn. This causes summer solstice for the southern hemisphere, and it causes winter solstice for the northern hemisphere. When the earth travels and makes its way to the opposite side of the sun's rays now hit at that northern latitude, the Tropic of Cancer. This causes summer solstice for the northern hemisphere, and it causes winter solstice for the southern hemisphere. Because we live in the northern hemisphere, we are drawing our seasons diagram by that perspective. When we have the halfway points between winter solstice and summer solstice and winter solstice, we have the two equinoxes. And at the equinoxes, the sunlight rays are directly on the equator. This, of course, causes our nights and our days to be equal in length, as opposed to our longer days and shorter nights in the summer solstice, and our longer nights and shorter days in the winter solstice. At this point in our illustration, we labeled the rotation that the Earth takes around the sun and finish labeling each of the seasons and the dates relative to that season. And that finishes up this illustration. There are several other illustrations that we're doing for astronomy, so follow if you want to see some of those, and check out the site, thebeautyofplay.com, to see the blog posts that go along with the details on how I taught astronomy.